Hello guys. Today we are going to see some applications on the topic capacitance. So the application I had taken is effect on electric field intensity, capacitance, charge, potential difference between the plates of capacitor, electrostatic potential energy stored between the plates of capacitor when a dielectric is introduced between the plates of capacitor while in the first case battery remaining connected and in the second case after disconnecting from battery. So let us see. In the first case the battery is remaining connected, the capacitor is connected to battery, and the second diagram you see the capacitor is connected to battery but a dielectric is being introduced between the plates. So let us see what would be the effect on capacitance, potential difference, charge, electric field intensity and electrostatic potential energy. Now capacitance in the first situation for the diagram shown is C. Now introduction of dielectric, the capacitance become K times C. Potential difference in the first situations, the terminal potential difference across the source is E. So in the second case the same potential difference is being applied across the plates of capacitor, so the potential difference is E. Regarding charge, the formula is charge Q is equal to C into V. Here V is E, so Q is equal to C into E. And the second case, Q dash is equal to C in place of C it is K times C into potential difference is E, so Kc into E, so charge becomes K times of Q. Now next is electric field intensity. The formula for electric field intensity is sigma by epsilon naught, and you know sigma is Q by A, so E is equal to Q upon A epsilon naught. In the next case the electric field intensity E is equal to charge now becomes K times Q, and you know the dielectric constant is also introduced along with epsilon naught, so these two K getting cancelled, so electric field becomes these two K after getting cancelled, the electric field intensity remains same. Next, electrostatic potential energy. Formula for electrostatic potential energy I had taken half C into V square, where V is E, so half C into E square, and the next case half in place of C it is K times C, and potential difference since it is remaining same, so the potential energy becomes K times of initial potential energy. Now let us see the next situation. In this case I had introduced the dielectric after removing the battery. So let us see what will the effect on the five quantities. Since the dielectric is introduced, initially capacitance was C, now it becomes Kc. And since the source is removed, so there will be no further exchange of charge. So charge will remain the same as I had represented Q here also and here also. Also Q is equal to charge into potential difference. So just for representation I had written it to be Q is equal to C into E. Now next, electric field intensity. Formula is sigma by epsilon naught. Sigma is Q by A, so E is equal to Q by A epsilon naught. In the next, the change in electric field intensity E dash will be Q upon, now K is being introduced along with epsilon naught, so Q upon K A epsilon naught means electric field intensity becomes E by K. It will reduce by K factor. Next is potential difference. Potential difference formula V is equal to Q by C, which is actually E, thus potential difference across the terminals of the battery. And in the next situation, V dash is equal to, since there is no change of charge, so Q upon, in place of C it is Kc. So Q by C was V, so it is V by K. So potential difference across the plates decreases by K factor. So it is V by K. Next, electrostatic potential energy, I had taken formula Q square upon 2C. So in the next it is Q square as charge is remaining same upon K C means capacitance is increased by K factor, so Q square upon 2Kc. So potential difference the electrostatic potential energy becomes U by K. So these are the changes that occur in this situation. Thank you.